The second section in Unit 5 is titled Solving Inequalities by Adding or Subtracting. So we're still in our main standard 8AF1, that's actually the standard we'll use this whole unit, but being able to solve inequalities with fractions, decimals, or integers that require the distributive property, and then also representing and solving real-world problems that involve inequalities. So for our examples today, we're just going to look at some that require us to add or subtract and then also to graph on the number line. So for number 1, we have m minus 6 is greater than negative 4. And just like an equation, you want to get the variable by itself. So you always want to think of your opposite operations. Remember that addition and subtraction are opposite. So when you see subtraction or subtracting 6, we want to add 6 to both sides. Just like an equation, you're going to bring down the inequality symbol. Okay? On the left-hand side, we end up with m, and negative 4 plus 6 is 2. So our answer to the inequality is m is greater than 2. So we're going to plot 2 on the number line. Remember, we always want to plot a number smaller and a number larger. And then we have to determine which way do we shade, and we also have to determine if we have an open or closed circle on 2. So because it's just greater than, we want to have an open circle on 2. We're not actually including 2 in our answer. And our arrow, or our inequality, is pointing to the right. We're talking about all the values greater than 2. And so we want to shade to the right. I'll be checking for two things excuse me, in your answers. I'm checking for the inequality here as an answer, and I'm also checking for the graph. So you have to have, you'll get a point for having the inequality correct, and you'll get a point for having the graph correct. Number 2, we have 7 is less than 4 plus c, and we need to get the c by itself. So you see that the 4 is positive, so we want to actually subtract 4 from both sides. And when I say both sides, it's both sides of the inequality. So on the left-hand side, 7 minus 4 is 3. We have, bring down the less than symbol. And on the right-hand side, the 4's cancel out, and we're left with c. And I talked about this in the previous lesson, but we always want our variable on the left. So in order to get the variable on the left, we're going to kind of like reverse everything. We're going to flip everything around. You're going to move the c over to the left, but move the 3 to the right, but you also have to flip the symbol. These two say the exact same thing. This says that 3 is less than c, and the bottom one says that c is greater than 3. So those two things actually say the exact same thing. So we're going to plot 3 on the number line. I'm also going to plot 2 and 4. We want an open circle at 3. And this is where it's really important to switch your inequality around so that your variable's on the left. If you didn't do that, a lot of you would look at this one here, that the first one we wrote, and you would shade to the left, but that's actually incorrect. We want C's, we want all the answers that are greater than 3, so that's why we shade to the right. And remember, with an inequality, the reason why we use the number line and the shading is because these are all of our answers. We can plug in any value that's greater than 3 and it will work in this equation. Any decimal, any fraction, any integer will work as long as it's greater than 3. And we can't possibly list all of those answers, so that's why we use the number line with the shading. I would like you to put a secret word in your notes today. It is election day 2016, so if you want to, or not if you want, but I need you in your notes next to example 3 to write the word vote. For example 3, we have p minus 4 is less than 1, so we see subtraction. We're going to add 4 to both sides. So it's going to cancel out the 4's. We're going to bring down the p, bring down the inequality. 1 plus 4 is 5. So we have p is less than 5. Our variable's on the left, so we can go ahead and plot it or graph it on the number line. We have another open circle at 5, and we're shading to the left. We're talking about all the values that are less than 5. Again, make sure that you do have the secret word written down next to this example. Here we want to write an inequality and solve it, but you don't have to graph. So for number 4, it says 4 more than a number is less than 11. 4 more than a number is less than 11. So I'm going to write underneath this sentence here some things that I recognize. I know that I have 4. More than means addition, and you have to be kind of careful here when you're reading, because we have more than and less than, which usually mean addition or subtraction, but we also have an inequality. So we have 4 plus some number. When you see the words a number, we're going to think of a variable, and you can use any letter you want. Is less than, so you're kind of looking for this word is when you see the words less than or more than. Because it's is less than, that's going to be our inequality. And the less than symbol points to the left, opens to the right, and then we have the number 11. So it looks like we have our inequality here, 4 plus x less than 11. However, remember from back when we did this with equations and expressions, the words more than indicate we have to switch our addition. So instead of saying 4 plus x, we're going to say x plus 4 is less than 11. So there's the inequality. You'll get a point for writing it, but we also have to solve it. And the solution is x is less than 7. So we write the inequality first, and then we solve it. Number 5 says 10 less than a number is greater than 32. So we have 10 less than means subtraction. There are the words a number again, so it's our variable. Is greater than, so that's our inequality, and then the number 32. Similar to more than, when you see less than, you also have to flip or switch the places of the two numbers. So instead of saying 10 minus x, we want to write x minus 10 is greater than 32. We're going to add 10 to both sides, and that's going to give us x is greater than 42 for our answer. So again, a point for the inequality and a point for the solution. Same thing with number 4, a point for the inequality and a point for the solution. So here are one of those represent and solve for the real world problems. Your baseball team has a goal to collect 160 blankets for a shelter. Team members bought 42 blankets on Monday and 65 on Wednesday. How many blankets must the team get on Friday to meet or exceed their goal? So we're writing an inequality, not an equation here. And then we also need to solve it. So let's highlight some things. 160 blankets, that's the total. And we've already collected 42 and 65. So you can actually have a couple different answers here, but off to the side, I'm going to add 42 and 65. And that gives me 107. So we've already collected 107. We need to know how many more blankets the team has to get on Friday to meet or exceed our goal. So when we want to get at least 160, that means that however many blankets we get should be greater than or equal to 160. At least. And this is where the word at least is a little confusing because it actually means greater than or equal to. Excuse me. When you say at least, it means you want 160 or more. So we want whatever's on the left to be greater than or equal to 160. So I don't know how many blankets we still have to get, but I do know that we already got 107. So if I take the number we need to still get plus the 107 we already got, we want that to be greater than or equal to 160. So we're going to subtract 107 from both sides. We get x is greater than or equal to 53. So that means that the team must get 53 or more blankets by Friday to meet or exceed the goal. Once you're finished with this lesson, you can show me your video notes and I will give you the next set of practice problems.